So this video will discuss part B of problem number 2 from the 2013 AP Calc AB exams calculator problem. And in part B here it says write an expression involving an integral, so we better write down something that definitely has an integral in it, that gives the position of the particle s of t, and then use that expression to find the position of the particle at time t equals 5. So I actually want to start with what's at the end here. I want to find the position at 5. So I want to find what s of 5 is. I think if we can determine this, it'll be easy to kind of write down a general formula that will determine the position at any time t. So I'm kind of going backwards here. So if I'm looking to determine what s of 5 is, what I need to do is I need to take into account the starting position at t equals 0, and the starting position is 10 units. So we're starting at a position of 10 units, and we're going to have to add on how much the position of the object has changed from t equals 0 to t equals 5. So we're going to have to integrate the rate of change of position from 0 to 5 to figure out how much change actually occurs across that interval, and the rate of change of position is velocity. So if we take our starting point into account and we add on how much the position has changed from 0 up to 5, we're going to have our answer for the second part of part B here. This is a calculator problem, so this is definitely not an integral that you're going to want to waste your time trying to use the fundamental theorem of calculus on. You're going to want to use your calculator's capability to evaluate this integral, so there's a graph left over from part A. I'm just going to try to evaluate this expression on my calculator, so I'm going with 10 plus an integral, and to integrate from the home screen I have to go into the math menu, and then I have this function integration tool here, and I need to carefully type in this function. Now your grouping symbols are going to be pretty important here, so I'm starting with -2 plus x squared plus 3x, end that set of parentheses, and then raise that set of parentheses to the 6/5 power, so that power is also going to have to go in a set of grouping symbols, and then I'm subtracting t cubed or x cubed from that. So there's the function that I want to integrate. My variable of integration that I typed in was x, and I want to do this integral from the x value of 0, so lower limit of integration, up to the x value of 5, our upper limit of integration. And calculator will think for a minute, and the position after 5 units of time is approximately -9.207, taken to 3 digits of accuracy. What would our formula be for the position at any time t? So our formula for s of t? Well, it's really going to be what we have right here, but with a little manipulation with the variable that's in this integral. So we're going to take 10 plus the integral from 0 up to, this is, sorry there, I misspoke and I had to rewind my video for a second. We want to do the integral from 0 up to t, right, the independent variable within this position function. And then within the integral, what we want is we don't want to have the same variable here as we have in the limit of integration. We're saying that s is some function of t. In this integral, I'm going to just kind of pick a different variable, and I'm going to go with x. Okay? So we would be doing the integral of velocity from 0 up to a certain t value, adding that value onto 10 to figure out the position at any time t.